Today I'm going to show you guys how to make the ignited Freddy AI. Now, I do assume if you're watching this video, you have a little bit of experience with circuits and animating and maker pen, stuff like that. So we're going to start off with the actual map for our ignited game. If you notice all of the ignited whatever games, they're always a very simple kind of maze with long straight hallways, intersections that are only like right angles, and no dead ends. So we're going to make a very simplified version of that for our example today. So now that we have our map set up, we're going to get our monster, and our monster is going to have two animations, a walking animation and a running animation. Then you want to go ahead and add your monster to both of these animation gizmos, animate your walking animation and animate your running animation. Then we're just going to leave this alone and come back to it later. Okay, now that kind of all of our physical assets are done, we're going to start working on circuits. And to start out, we're going to just get a cube. And this is going to be our monster for now. You want to make sure that you center the pivot point. So select, click that, options, center pivot on selection. You also want to configure the cube and give it a tag we're going to use for our enemy. I'm just going to use the tag E. And you're also going to make sure you scroll down to the bottom of the configure page and make modify with circuits on. Today's video is sponsored by Kiwi Design, your one-stop shop for all MetaQuest and VR accessories. For the past week, I've been using their 16-foot link cable so that I can have the PC VR experience and use the streamer cam without having to be so closely tied to the PC. And it's a pretty thick cable, making it more durable and less likely to break or short out. It also comes with these two clips to hold the cord while you're playing. I've also been enjoying these Quest 2 headphones. These are dedicated headphones for my Quest, and with them I'm always ready to hop into VR without having to search for a pair of headphones. Use my special link below, go to their store and check out all of their useful products for all Quest users. They've got head straps, battery packs, protective covers, all that and more. And thank you again, Kiwi Design, for sponsoring this video. We're going to start off with a rec room object, get first with tag, and change that tag to the tag on our cube, which is E. Next, what we want to do is have it constantly changing the position of the monster to be closer to the player that is the current target. We're going to use a set transform because it includes rotation. Now let's work on filling out this chip. So we know that our target is going to be our object. Now the position that we want to give it is going to be the position of the monster plus a small chunk of the vector between the monster and its current target. We're going to use one of those new chips called the Get Closest. The origin is going to be the position of our monsters. Now for the targets, I was going to do get all players originally here. Now I figure you guys would most likely want it to be like the players who are currently in the game. So I'm going to do get all players with role, and we'll just make one. We'll call it food. Change this to food. So now that we have our target, we want to get a vector between the monster and that target. And we're going to subtract the position of the current closest player from the position of the monster. So after reviewing my notes, I need to make a small change here. When it tracks your position or the position of a player, it's actually like the spot beneath where your feet would be. We kind of want it to target right here or somewhere up a little bit more. So we're going to take the position of the closest player and we're going to split the vector, add 1 to the Y, and then combine it back to make the vector again and subtract that. Incidentally, this will actually give us the rotation that we need on our set transform chip. All right, so we have this vector which is between the monster and the player. And what we want to do is chop that vector up into smaller chunks and then add those small chunks onto the position of the monster. So first we're going to normalize the vector. Then we're going to use vector scale, put the result from your normalized into that. The scalar can be a float or an integer. So I'm not a game developer. I'm not like trained in that way. A lot of people use this delta time. I don't exactly know what that is. Let's try it with delta time. I think it's something to do with the frames, and I think maybe that will work. So we're going to take the current position of our monster and we're going to add the result of this vector scale, and then we're going to put that sum as our new position. So remember, back there we have it only following players with that role. So here we have a player add role. I'm going to have it add the food role to me, the local player. Go ahead and hook that up. And now that I have the role, our cube's following me. So now, assuming there were other people in here, it would follow the closest player, except we have some networking to do. So as it is right now, all of these circuits are running on everybody's system all at once. We need to make it run on just one person's system. In the past, I've done this with a is room authority chip, but instead we're gonna make it the person who has authority over this cube that's chasing us. We want a rec room object get authority. We hook it up to our monster down here, and then the result there will be a player, and then we want to make sure that we're only running on the system of the person who outputs there. So for this next part, what we need to do is measure the distance between the monster and its current target, and then if that distance gets too big, then we want it to stop following. We start with if chip, want to get the distance, let's do a less than. So we want to get the distance of the monster from the distance of its current target, which is the closest down here. Then we're gonna take that distance, and if that distance is less than, I don't know, let's say like 5, then we're gonna hook up the bool variable here. So if it's less than 5, it'll be true, which then means we want it to start following. But if it's not, then we want it to stop. So if we hook this up now, it's following me, and then when I get too far away, it'll stop. Let's multiply the delta time by 2 and see like how much faster does it get. Oh yeah, he's faster. 100%. All right, we have a system now that it follows the closest player, and if you get too far away from it, it stops chasing you. Now comes the real ignited Freddy part. So let's step away from these circuits for a moment and work on this map. What we're gonna do is put a trigger volume at each intersection of our map. Then we're gonna go back to our circuits and set up some circuits so that it chooses the closest trigger volume to it once it stops following you. You also wanna configure them so that they only detect your enemy. If you could do it on the first one and clone it, that would be the easiest way to do. And honestly, for this, we're gonna clone a lot of these circuits we've already used. So we're definitely gonna use the set transform again, add again. We're gonna need the scale, normalize. I suppose if we are multiplying, we can use that as well. The subtract we'll need. We're gonna need the get closest. I think that's what we need for now. So if it's too far away, then, or else rather, set the position. We're gonna set the position of the same thing, which is our monster cube. Actually, I'm just gonna clone. These are just circuits that we already have, the get position stuff. So we have our object E, and we want that to still be the target. We want to do the same. We want to subtract the position of this from the position of our closest trigger volume. We want to normalize that vector. We want to get a small section of it, which will use the delta time, or which will use the multiplication of the delta time. We're going to add that result to the position of our current monster and put that in as position. And then that subtraction is our rotation. The origin, again, is the position of our monster. And it's here that we run into a bit of an issue. We want a list of all of the trigger volumes, but there isn't any trigger volume list variable that we can use. So what we're going to use instead is a list variable of vectors. And we're going to create that list variable of vectors from all of the trigger volumes.
5 minutes later.
Okay, let me preface this by saying that I am not an expert. There's probably a better way to do this, but this is the way that I figured it out, okay? Here I have detached all of the boards for our trigger volumes over here. And the colors indicate which one is which. So the yellow board goes to the yellow trigger volume, which is this one over here in this corner. You see what I'm doing here. So what we're gonna do is have an event receiver set to room loaded. Then when the room is loaded, we're going to create a list of vectors, and each of the vectors is going to be the position of a trigger volume. Okay, I don't know if that makes sense, but we're gonna try. So the room loads and it defines the list of vectors. Okay, this list of vectors, each one is going to be the position of an individual trigger volume. Well, apparently you can't sync list. So we're gonna have to add an event receiver that also hooks to this for whenever a player joins the room, because if they become the authority of the object, we also want them to have access to this list. All right, so we're gonna clone this. bring it down to our get closest from earlier. So let's go ahead and define the list, give ourselves the role. Now this should chase me if I'm too close, and if I'm not too close, find the closest one of the colored trigger volumes and go to it. But once it gets there, it kind of doesn't know what to do. What we're gonna have to do is every time that that box enters one of these trigger volumes, it's gonna have to randomly pick one of the adjacent trigger volumes to then go to. Each one of these trigger volumes has to have its own circuits. They're all gonna be a little bit different because, like, for instance, the middle one, if it reaches the middle one, then it has a choice between that one, that one, that one, or that one. But if it reaches a corner, then it has a choice between only that one and that one. Let's start with this blue one down here. And we're gonna have to do random from list. Object entered. So again, we're at blue, which is in a corner. So it's only gonna be between that one and that one. So we'll get another list create. So we wanna get the vector that's the position of this one, but then also the vector that's the position of this one. And then from that list, we're gonna have it define a vector variable. Okay, so in experimenting with this, the monster will hit the trigger zone and immediately flip to its next one. We don't want that. We want to add a little bit of a delay. So we're going to add a really short delay, like half a second. I'm also going to sync that vector variable. Okay, now because it is output as a vector variable, and that's going to be the new thing that our monster's aiming for, we're going to have to kind of change what our system does over here. So because this value is going to be changing every time that we switch to a different trigger volume, we then need to change this into a copy of our vector variable. This creates a problem because when it switches from following us to trying to follow the closest, now it has no way to determine what the closest is because we're not defining this variable. So we have to make kind of a convoluted system to make it define this new vector variable every time that it loses the player. I'm going to set this up and then try to explain it. Get a if chip and a bool variable. Again, make it sync. And you also want to clone that bool variable. We're going to move our new vector variable up here. So on our very first set transform, the one that goes off when it's actually following the player, we're gonna hook this bool variable up and leave it as false. Then we're gonna take this else from when it's checking if it's following a player or not. We're gonna hook that up to our new if chip. We're gonna hook up this new bool variable to that if chip as well. We're gonna hook the then up to our set transform. We're gonna hook up the else to this bool variable and flip it to true. Then we're gonna hook up this execution from the bool to our new vector variable. And we're gonna hook up our vector variable down here to that closest vector from that vector list. So now what's happening is it's following the player and it's constantly setting this bool variable to false. Once it loses the player, it's gonna come up here and say, well, is this bool variable false? If it is false, it's gonna go through down here, flip it to true so that the immediate next execution goes up instead of down, is then going to define this variable as the closest vector in this vector list. So essentially, once it stops following the player, it finds the closest vector or the closest trigger volume to it and goes to that. Now, when we go back over here, we're going to set up everything so that all it changes is this vector variable, and when it hits a trigger volume, it can switch this vector variable to whatever the next one needs to be. So let's say, just for example, that it was this blue one, the blue trigger volume. It will lose the player, it will go to the closest one, which in our example is this blue one. Once it enters the blue one, it'll go through a delay, and then it will pick from the list of either this one or this one to go to next. Once it picks it, it'll define our new vector variable and switch it over on our circuits over here. So then it can just continue on with where it needs to go. So now that we kind of have that system figured out, what we need to do is essentially copy these circuits and make them for each individual trigger volume. Now the difference for each one of these is going to be how big the list is and what are the adjacent trigger volumes that we're going to use. So this one down here only had that trigger volume and that trigger volume that it could go to. But this one right here needs an extra thing for the list because it can go down, it can go up, or it can go in the middle. Now we actually have to add 2 to the middle one because it can go down, it can go left, it can go up, or it can go right. Make sure that you connect these object innards over here. And it's just the same for all of these. So just make sure that you have major lists for however many, whichever direction they can go. All right, let's test it out. It should follow me, and then if I get too far away, it should roam around by itself. Oh, okay, all right. Yo, you scared me, dude. Okay, all right, hold on. Okay, so it should, because I'm too far away, it should pick a random, right? And then it chose to go over here. I'm too far away, it's choosing to go that way. All right, and then it chooses to go this way. It's working, but there's a small glitch going on, and I wonder what that's about. All right, so I fixed it so that when you join the room, it kind of automatically starts roaming. So what I did was I added in another if chip that if that list of people with the role equals 0, then go ahead and do your like normal kind of walking and searching. All right, now we can go back and add in our actual monster. All right, you see this thing in the middle, the pivot point? You want to put your blue line where the front of your, like toward the front of your monster, and the red line to the right. That should work. You can also do this with an invisible collision. Just since we all already have it set up, I'm not going to do that. You want to get yourself a clamp. You have this, and then you want to clamp your animation gizmos to this top pin thing. Clamp those, and then clamp the bottom bit to the cube. So now when I turn this back on, the cube will start moving and the animation gizmos will follow, but the monster won't. When I want the monster to start following, what I've got to do is actually turn on one of the animation gizmos. Here you should see him start to run around, do his thing, be a monster. Again, I don't know what is up with that glitch. So somehow the multiplication of the delta time is what did it. That's nuts. Okay. So here's what you can do if that doesn't work. Let's do a float variable, and we'll put it over here with the stuff that gets defined when the game starts. 0.0333. Okay, put that there. Clone it, pull it over here so that it's the scalar. All right, so now it's kind of running at normal speed in a way, and it's not glitching. Let's get an additional float variable, 0.0888. Make that defined when the room is loaded, and take this one and hook it up to when the player is being chased. Because usually in Ignited Freddy, it's like whenever the player is being chased, the thing gets faster, right? So this way, when it chases the player, it's going to be faster, and then when it's just roaming around, it'll be slower. Now, I think all we need to do is a CV1 CV2 converter so that when it finds me, it will switch to a different animation. We're going to get an event receiver, and we're going to configure it to when this bool variable changes right here. So that is bool variable 1. When it changes, we want to have it either add or remove a tag. Then we want to add in an if chip. You watch, I bet in the next week they're going to release animation v2 and make this so much easier. So whenever that bool variable changes, we want to check and see what the bool variable is. If it gets changed to false, that means that it's chasing the player. So if it's false, then we want to add a tag to it. What target do we want? So this is where, again, we're doing CV2 to CV1. So we want a legacy trigger here. Then let's get some sort of a cube. Then we want to configure the trigger volume so that it detects objects. So also on this cube, give it a tag. We'll just call it the animation cube. We'll get a rec room object first with tag. The target for both of these is the animation cube. It should get that cube that's in there. If it starts chasing the player, we're going to add the tag run. Okay, and then if it isn't chasing the player, we want it to remove the run tag. All right. So now we want this trigger volume to detect the cube only when it has that tag of run. So now we got to do some CV1, get a compare. So right now it has currently in zone 0. So if it equals 0, then this will be 1, which means we need to play the walking animation. So let's play the walking animation and let's stop the running animation. Okay. But on the flip side, if it is not equal to 0, meaning this will be 1, then we want it to play the run animation, but stop playing the walking animation. Walking. I might need to up. It's running. I think it's running. Walking. Yeah, it looks like it's working. It's still following me a bit low. So let's add maybe 2. Okay, no, it's too high. So you have to find the right kind of height. Maybe I could have it aim for your head. Really? The only thing left we have to do is for you guys, and that's to attach noises to them, attach the trigger volume on the front, attach this up here. So, you know, we have the seat here, player enters, they get sent to the seat, and then we'll also do lock players in. You can also add audio. You would do the same thing, just attach this right there. And what we would do in that case is probably have audio player play. My computer, everything is not happy because I don't have enough. My thing's about to die. Audio sample there, audio sample there. This is your running and this is your walking. So the target will be your audio over here. You can have it play that and then play that one. And then I believe there's a setting on here to loop it. You loop it, right? Loop the audio. Leave me alone. Okay, there we go. All right, now he should go back to roaming around randomly. Yeah. Well, even though it's not perfect, hopefully at least you guys have some idea of how to make this now. And if you liked the video, like, subscribe, all that good stuff. And RCL Man out.